So I don't know if your parents are anything like my parents, but when we would sit down at the dinner table, my mom would turn to me and say, "What did you learn in school today?" And if I said nothing, then I got a big lecture about how she spent all this money on educating me and all this time driving me to school, and how did I not learn anything? And it was so not worth it. So if I had just one thing I could pull out and say, "Oh, I learned this today," then she'd feel much better about the world. Okay, so in the interest of keeping your parents very happy, here is your one topic for when they say, "Hey, what'd you learn in school today?" You say, "Polymorphism," and then they'll feel so good. It turns out that it's a really easy idea with a really crazy hard name. So practice saying it, polymorphism. Okay. Do you feel ridiculous now? Join the club. All right. So polymorphism is in section 9.3 in your textbook. You should check it out. This is my version of it. I'm changing the definition to be less accurate, but more what you'll see in this class. So we will normally see this in client code. Actually, what polymorphism is treating a bunch of different types of objects as if they were all of the same type. And I threw superclass in there because that's kind of how you're going to see it here, right? We talked about a vehicle hierarchy. So you have vehicles up here, and then a car is a vehicle, and a motorcycle is a vehicle, and a truck is a vehicle, right? And you could put all of those things into one array, and you could treat them all like they were vehicles. Or you have a hobbit, and a dwarf, and a wizard, and you can put them all into a traveler array, right? They're all kinds of travelers. You can put them into a traveler array and treat them all like travelers. So you're taking objects of one type, a hobbit, and treating it like another type, a traveler. Treating an object that, say, okay, maybe it's a car, and we're going to treat it like a vehicle. So you can do this even when you're creating a new one. So you would normally expect me to write like new vehicle, something like that, right? But this time, I'm going to create this vehicle, V1, and as far as Java is concerned, it's a vehicle. But I'm going to use the car constructor to create it. And to make vehicle V2, it's a vehicle, but I'm going to make the motorcycle constructor set it up. So it has all the abilities of a motorcycle. It's set up to be a motorcycle, but as far as Java is concerned, it's going to be treated like a vehicle. Now this works because we have that inheritance relationship, where a motorcycle extends a vehicle. So it has all of the functionality of a vehicle, but it may also have its own special stuff. Okay, so new, let's make this a new semi, right? It's a new 18-wheeler. Okay, and we can create a list of vehicles and put them all in it, V1, V2, and V3. All right, so they're all in there ready to go. So we're going to talk about maybe what kinds of methods we can call on them. And it's not quite as obvious as it at first seems. The devil is definitely in the details in this one, right? All right, here's our vehicle hierarchy that we were just talking about. You have vehicles up here, cars, motorcycles, and semis. A semi is a vehicle. So we have the is-a relationship working. These are the methods that I've put just in the vehicle class. So you will wash the vehicle, fill it with gas, and maybe there's some other ones. Let's start there. So here's a for loop continuing the code we were just writing. For vehicle V, for every vehicle V in VList, v.wash. Okay? So V will take on vehicle 1, which was a car, and we'll wash it. And the car washing code lives up here. So car is an extension of vehicle. It'll go find the wash method up there. No big deal. It'll work the same way for motorcycle. It'll go up there. Semi, it'll go up there. Now, if I wanted to fill it with gas, I can still write v dot fill with gas. And an important thing to note is that all of these things that you call, all these methods that you're calling, must be vehicle methods. They must be things that everybody knows how to do, because you have only promised Java, the compiler, you've promised the compiler that this thing that you're calling the methods on, that it's a vehicle. So you are only allowed to call vehicle methods. That makes some amount of sense, right? So you don't want to like call, I don't know, something that motorcycles could do, say wheelie, right? You don't want to say, hey, v.wheelie, and then suddenly have a semi to, okay, well, we've proven on YouTube that that's possible, but this is a terrible idea, right? So you don't want to accidentally, at least, call that and have a semi or a car be required to do that. That would be very odd. Okay, so we've got fill with gas, all right? When you run fill with gas, on V1, the car will go look up here and get this fill with gas method. The motorcycle, V2, I think, right? The example of a motorcycle object, that instance will go find this and use this code. V3 was a semi. It was a vehicle, but that was created with a semi. So it will use this code. So even though it was vehicle V3 equals new semi, it's going to go for the semi code first. If it doesn't find it, it would go up here just like the other ones. So it will use this one. So even though you call it the same for each and every instance in the array, they may actually be running different code when you call it. If you've overridden the method, it'll run the most specific one that it can run. Hopefully that makes sense. All right. Now, you could also do something like this. Say we wanted to replace tires in a car. I could replace tires here, right? Replace tires. So I'd jack up the car, I'd pull off the 4 tires, put new ones on. Motorcycle, that would be a little bit different. Like the process for getting them off, like I'm gonna have to have separate code here to replace my 2 tires on the motorcycle. It's gonna be slightly different than here. And it's definitely gonna be different if you have to somehow get, like, how does that work? I don't even know how they change the tires on an 18-wheeler, but if you had to do that here, great. Now, there's something kind of funny about this, because if I do this, it's not going to work. Even though each and every one of these vehicles that are in here have this, a vehicle itself does not have that method. So you have to make sure that up here you put replace tires right up at the top so that you can call it, it's a vehicle method, and it can be called for any of these. And then each one of these will run their very own version of it. Does that make sense? Each one will run their very own version of replace tires. But you had to have a version up here that they override so that you could call it on all of them. Yeah? Okay. I hope that works. So a couple things I just want to clear up, all right? First, 2 things happen when you hit the run button. First, the code decides whether or not it's going to run. That's when the compiler is checking your code. So when the compiler checks this, it says, this is a vehicle. So it sees this part and makes sure that any methods that are called on V are vehicle methods. So that is the first thing that happens when you hit the run button. So all of the code you write has to pass that check. You have to make sure the compiler knows, hey, I'm only running vehicle methods on this thing. The second thing that happens is that the code runs. When the code runs, it doesn't run as if it's a vehicle. It was set up with car code. So it runs as if it's a car. This means that when you call fill with gas, this car, well, it runs like a vehicle, but this one runs like a semi, right? Instead of putting in regular unleaded, we're going to put in diesel, right? So the semi, it's going to pass, if you say like V dot fill with gas and V is a semi, then it will run this code here. It'll pass the check because it's got vehicle code, but when it runs, it will run semi-code. Okay, so 2 things. First, the compiler checks, and you have to write code that passes that check, and then it will run as whatever you created it as. If you created it as a car, it'll run as a car. If you create it as a semi, it'll run as a semi. Okay? All right, next piece. Let's see if that made sense to you. So convince yourself of whether or not this is going to work. Vehicle V4 equals new motorcycle, V4 dot wheelie. Is that going to compile and run? Think for a sec. Have a reason? All right. It's not going to compile. So this would actually run just fine. This is created with a new motorcycle. It would run just fine because motorcycles, they can do wheelies, no big deal. Problem is that I've created this new motorcycle as a vehicle. When I've created it as a vehicle, the compiler says wheelie is not one of those things in the vehicle code, so it won't run it. This is not going to work. Now you can force it to work. You can force it to work. And the way that you force it to work is a little crazy, but I'll show you. I'm going to make a little space here. Okay. Now remember, the only thing that didn't work about this is that it doesn't pass the compiler. It would run fine, but it doesn't pass the compiler. So if you had v4.wheelie and then you said, hey compiler, I know that it doesn't look like it, but this V4 is actually a motorcycle. If you cast it as a motorcycle, this is you promising the compiler. This is you promising the compiler that V4 is actually a motorcycle, and the compiler will say, okay, well a motorcycle could do a wheelie, so I guess that's okay. So in the instance where most of the time you're taking, hobbits and wizards and dwarves and you're treating them as travelers. You always treat them as travelers. But you get to one specific spot in your code and you're like, gosh, dang it, I really want the wizard to cast a spell. You could say, hey, I know this character is a wizard. I'm going to tell you just for this one instance, he's going to cast a spell this one time, okay? And you could downcast him to be, instead of a pure traveler, you could downcast him to be a wizard and let him do his thing. Or instead of this thing being a vehicle, you can say, no, actually, I promise you, this is actually a motorcycle. He's allowed to do this. The compiler will go, okay, hands off. Like, if you think he can do it, then go ahead. Knock yourself out. All right? This is called, the word I've been using over and over is called downcasting. Okay, so it was an object of the parent type, but we've downcast it to be an object of the child. It has to be set up that way. Like, it has to be new motorcycle. You can't just go cast it into like a kitty cat or something, right? But if you can actually promise that it was set up this way and it has the ability to do this, then you're allowed to force it to work, okay?